welcome back. This is Mr. Hassan's Maths channel. I'm now answering a question from the May-June 2009 IGCSE Cambridge 0580 exam. This is paper 2 variant 1. And this question here, I've been requested to answer part B of this question, but I'm going to go through part A as well. Now, at the time of answering this question, which is in November 2023, the syllabus is about to change. It's already changed. I mean, the new syllabus is already being taught now in this 2-year syllabus, and the first exam will be in, I think it's going to be in March or June of 2025. That will be the first exam. Probably March of 2025, with the first exam of this new syllabus, where there's some major changes made to the structure of the exam. So you're going to have a calculator paper and a non-calculator paper, and that's the main kind of difference. So I'm going to actually answer this question as if it's a non-calculator paper, because this is a type of question which I assume would be a non-calculator question in the new syllabus. Okay, so I'm going to tackle this as if it's a non-calculator paper, and this question involves manipulation and arithmetic operations with numbers in standard form, which will be something which you won't be able to do just on your calculator like in the past. So that's how I'm going to tackle this question. All right, so now for part A, it says there are 10 to the power of 9 nanoseconds in 1 second. Find the number of nanoseconds in 5 minutes. Okay, so we can set up a proportion here. So we want to find how many nanoseconds there are. I'll just put it as ns. Okay, in 5 minutes. And we know that there are 10 to the power of 9 nanoseconds in 1 second. Okay, so what we can do here is we can cross multiply, but before doing that, we can change 5 minutes into seconds, so the units are the same. So 5 minutes is 5 times 60, which is 300 seconds. So this is 300 seconds. Okay, so if you want to find what x is here, we can just simply cross multiply. It's going to be 300 now times 10 to the power of 9. So we have 300 multiplied by 10 to the power of 9. Okay, that's the number of seconds there are. The nanoseconds there are in 5 minutes. All right, so we want to give the answer in standard form. So give the answer in standard form. Now what we have here is this number. It's not in standard form. The reason why it's not in standard form, a number in standard form should have a digit before the decimal point, only one digit, which is non-zero. Okay, so the number before the decimal point, there can only be one digit before the decimal point, and it can't be zeros. It could be any number from 1 to 9, but it cannot be 0, all right, before the decimal point. And then it's multiplied by 10 to the power of something, all right? So this is not in standard form because you have 3 digits here before the decimal point. So what we want to have to do is we have to make this into the number 3. So this has to become 3. So you ask yourself, how does 300 become 3? Well, you have to divide it by 100, right? So this is going to become 3 times, now, I want this to be the same as that. I want these to be the same. So if I divide this part by 100, sorry, I have to multiply this by 100. Why? So then it's the same value. I haven't changed the value of this thing. So I divide this section by 100. I have to multiply this section by 100. So that's 10 to the power of 9 times 100. So that's 10 to the power of 9 multiplied by 10 to the power of 2, which is 100. And you have to add the power, so it's 10 to the power of 11. So you end up with 3 times 10 to the power of 11 as your answer. Okay, so there's the answer there. That's now in standard form. Okay, so there's part A. Then part B says solve the equation 5 times x plus 3 times 10 to the power of 6 equals 4 times 10 to the power of 7. So here's like an equation that we have to solve for x. We can tackle this in 2 ways. I could expand the bracket first and then find what x is, but I think it will be easier to actually divide both sides by 5 first, because the whole of this side is multiplied by 5. So if I divide both sides by 5, I'll end up with x plus 3 times 10 to the power of 6 equals 4 times 10 to the power of 7 over 5. Okay, if you do 4 times 10 to the power of 7 over 5, you end up with 0.8 times 10 to the power of 7. So you have x plus 3 times 10 to the power of 6 equals 0.8 times 10 to the power of 7. Okay, so now we want to solve this for x. So I'm going to do x equals 0.8 times 10 to the power of 7 minus 3 times 10 to the power of 6. Okay, now if I want to subtract two numbers in standard form, like in the past, student would just probably put this in the calculator and get the answer, and the answer would show in standard form in your calculator. But as I said, I'm going to assume, or I'm going to act as if this is a non-calculator paper for the benefit of those students who will be taking this after 2025. So what we're going to do is, when we add or subtract numbers in standard form, we have to make sure that the numbers that we subtract have the same place value, right? So 3 times 10 to the power of 6, there's going to be like 6 zeros after the 3. And 0.8 times 10 to the power of 7, you're going to have, the decimal point move over here. Then you'll have 6 zeros after the 8. So the 3 and 8 are actually in the same position, and I can add them together. So I can't just do 0.8 minus 3. I have to make sure that the decimal points are in line with each other. As we know, when we are subtracting decimals, like if I have 5.37 and I'm subtracting from it, say 0.02, I can't just subtract the 25 and the 2. I have to make sure that these are in the same place value. So I have to put here 0, and then the decimal points must be in line, and I put 0.2. Now these numbers are in the same place value, and I can then subtract. Now in this case, what I'm going to do is I'm going to write these such that we have the same power of 10. So 10 to the power of 7, 10 to the power of 6. In this particular case, I'm going to make this into 10 to the power of 6, because I can see if I make this 10 to the power of 6, I have to divide by 10, which means I have to multiply this by 10. That will give me 8 times 10 to the power of 6 minus 3 times 10 to the power of 6. Now I can just subtract these numbers. So it's like 8 million minus 3 million, which is 5 million. So it's 5 times 10 to the power of 6, and that's my answer. In general, what normally is the case is you normally make the lower one higher. Okay, but in this case, we can see that making the higher one lower actually gives our answer such that in the end it will be in standard form. If I had decided to make the lower one higher, like that means I'd have to multiply this by 10 and divide this by 10, I would end up with 0.8 times 10 to the power of 7 minus 0.3 times 10 to the power of 7. I'll end up with minus 0.5 times 10 to the power of 7, which I would then have to convert into standard form, because as I said, the number before the decimal point can't be 0. So I'd have to basically multiply this by 10 and then divide this by 10. I end up with 5 times 10 to the power of 6. So I could see at this stage, it's easier for us to, it's quicker for us to do this such that we end up with, 8 minus 3. So that's why I decided to change this into 8. And if this becomes 8, I have to multiply it by 10. Therefore, this part I have to divide by 10 to the opposite so that it remains the same value as that. And then we can proceed. So that's how to answer this question. The question that was asked was part B. And I hope that was clear. Now, up until 2005, if you were to just basically, at this stage, use your calculator, you would, if you just write that answer down, that would normally be fine. Okay, but after 2005, you won't have a calculator for you to use. So you must understand this very important point here, especially for those taking the exam after 2005. Okay, so that concludes this question. Now, the question doesn't say actually give your answer in standard form. So I could write my answer as 5 million. 5 million, even in words if you want, or as 5 and then million. I could write it like this. It doesn't really state it, but as the question has standard form in its format, I put the answer with standard form in its format as well, and that's fine. Okay, so that concludes this question number 14 from the June 2009 IGCSE Cambridge paper 2 variant 1. Other questions from this paper will be found in this playlist over here. Okay, these old papers, I don't really answer questions from them unless they are by request. So you could request other questions from this paper if you, don't find it answered, or any other questions that you don't see answered. If you would like me to answer them, I would, try to do so as soon as possible. Other questions from the topic of standard form can be found in the playlist over here. Other questions from solving equations in this playlist over here. You can subscribe to my channel by clicking on this link, and the video that shows up the link here that shows up as the video is playing, that takes you to a video which shows you how to use my channel, and you can find A-level material and Cambridge, Edexcel, and whatever. You can find the material that I have easily by watching that video. I'll show you how to find it easily. Thank you for watching, and see you soon.